Welcome to class. Today marks the second day of our tutorial titled The Ultimate Software Development class. If you've not watched the previous video, I will advise you to go and watch it. Today we'll be looking at the evolution of application development, focusing on standalone and cross cross-platform application, technologies and programming language for web, mobile and desktop application. By my right hand side, we have our objective for today's class, where we'll be looking at application development, and under it we'll be looking at standalone application and cross-platform application. We will focus on standalone application, where we'll be looking at Android application and focusing on Android apps and iOS apps. We also move to desktop application, focusing on Windows apps and macOS apps. Then finally, we'll look at web application. Without wasting much of our time, let's dive into the class. What is standalone application? Standalone application is an application that is built specifically for one platform and runs only on that platform. For standalone application, we build our application focusing on a particular platform. If you are to build a mobile application, you should ask the question, which platform am I building for? If you choose Android, then you have to select the tools like IDE, framework, programming language, which will be used for building application for the Android platform. Next, we'll look at cross-platform application. Cross-platform application is built once and can run on multiple platforms using the same code base. You can use a single code base, like build a single application that will run on multiple platforms. For example, if you choose a mobile application, you can write a single code to run on both Android and iOS platform. In standalone mobile application, all the logic, UI and data handling lived inside the app itself. No separate backend server, data was stored locally and they were mostly offline. They are built separately for each platform using their platform native UI framework and language. Examples of this standalone application: we have our calculator app, we have our English dictionary app, and we have our note apps. On the screen, we have a table which breaks down how the Android and iOS application is built. We'll be looking at tools and also the UI logic and data that helps us to build both for Android and iOS platforms. So for Android platform, we have IDE, which include Android Studio, and in Android Studio we have this SDK known as the Android SDK, which has all the features or resources used for building the Android application. For building the UI of Android application, XML was first introduced. Java acts as the programming language, which is used for logic, while SQL was used for storing data. Jetpack Compose was later introduced and used Kotlin as the logic. Kotlin is a programming language. Then SQL was used for storing data. For iOS application, the Xcode is an IDE that have been used for a long time for building iOS applications. For the interface, zip file were used, while Objective-C acts as a logic or programming language for building the logic. Data was also stored in SQLite. Storyboard was also introduced for building the user interface for iOS application. Storyboard worked with Objective-C programming language, which was used for building the logic, while data was stored in SQLite or core data. Later on, Storyboard was replaced with SwiftUI, and SwiftUI also came with its own programming language known as Swift, which was used for writing the logic, while data was stored in the Swift data. For building Android application, Java was the core programming language used and served as the backbone of the application. Java handled the logic, controlled behavior of the UI, managed events like click and gesture, and interacted with the operating system. XML, known as Extensible Markup Language, was used for UI. It's a markup language used to structure data and describe layouts. Later, Google officially adopted Kotlin in 2017 and made it the preferred language in 2019. So initially, Java served as the core language, handling application logic, controlling UI behavior, managing events, and interacting with the operating system. In 2017, Google officially adopted Kotlin, designating it as the preferred language by 2019, while XML played a crucial role in structuring data and defining layout within Android applications. Kotlin was used for logic and written in .kt files. Kotlin is 100% interoperable with Java. Each code essentially talks to the SDK Java-based classes to create UI and handle system events. XML or Jetpack Compose was used for UI. Jetpack Compose is a declarative toolkit where you write the UI entirely in Kotlin code. Jetpack Compose is a new way to build user interface in Android using Kotlin. Instead of using XML, developers wrote the UI directly in Kotlin code. This makes it easy to create and change the UI as the app data changes. Jetpack Compose helps developers to work faster and keep the code clean. Now we'll be looking at monolithic iOS application. For building iOS applications, everything was built with Objective-C, which was the core programming language used. Objective-C built the application logic and controlled the UI. Zip stands for XML Interface Builder, and it was a file format in Xcode used to design a single piece of a user interface using a drag and drop feature. So for building iOS applications, Objective-C was used as the main programming language, and it handled the application logic and managed the user interface. Zip file used in Xcode helped design parts of the user interface with a simple drag and drop feature. Zip was later replaced with Storyboard in 2012. Storyboard is a framework in Xcode used to build the user interface of an application. It lets you design the layout, buttons, label, and image by drag and drop, as well as manage navigations between screens. You then connect UI elements to your code, which is Objective-C. Storyboards allow developers to see and manage multiple screens in a single view, which makes it easier to visualize the app flow and design the navigation between different screens, improving overall organization and efficiency in development. While zip files are limited to designing individual screens, making it harder to see how they connect and interact. Later in 2014, Apple introduced Swift. It was safe, fast, and had high performance. Swift succeeded Objective-C and became the modern programming language used for building the logic of many applications on Apple platforms. Swift UI also succeeded UIKit and was used to build the UI of modern iOS applications. It allowed developers to write declarative code using Swift that described what the UI should look like. Swift is safer and faster, which makes it easy for developers to write high-performance applications. UIKit is a framework used to build user interface for iOS applications and provide essential tools for managing layout and interactions. Swift UI, on the other hand, is a more modern framework that replaced UIKit. It allows developers to write declarative code, making it simpler to design user interface and manage their behavior. When we say declarative code, it is a programming style that focuses on what the program should accomplish rather than how to achieve that outcome. In Swift UI, we can define a button appearance and behavior in a straightforward way, focusing on what the button should do when tapped. So in monolithic mobile application, the programming language like Java, Kotlin, Objective-C, Swift handles everything: the UI, the logic, system interaction. Think of user interface like XML, Zip, and Storyboard like HTML for Android and iOS app. But they are not separate language like HTML. They are platform-specific UI definitions controlled directly by Java or Objective-C and are compiled into the application. Now it's time to see if you are actually following up in today's class. We have few questions to answer, and this question is a continuation of the previous class we had where we stopped at question 3. When I read through the question, all you have to do is provide the correct answer in the comment section. If the answer is A, just comment for A. Question 4 says, what best describe a cross-platform application? An application that runs only without internet, an application built separately from Android and iOS, an application built once and run on multiple platforms using the same code base, an application that stores all data locally, an application that works only on desktop computers. So provide the correct answer. Number 5 says, which statement correctly describes standalone mobile applications? They depend completely on cloud platforms. They depend completely on cloud servers. UI logic, data handling are separated into different services. They are built once and deployed everywhere. All logic, UI, data handling live inside the app itself. They require HTML and CSS for UI. Number 6, which combination correctly match Android development technologies? Swift for logic, storyboard for UI. Java or Kotlin for logic, and XML or Jetpack Compose for UI. Objective-C for logic and XML for UI. Kotlin for UI only and Java for database. Swift UI for logic and Java for UI. So provide the correct answer to number 6. Number 7, why was Kotlin adopted by Google for Android development? It completely replaced Java and cannot work without it. It is only used for UI design. It is 100% interoperable with Java and works with Java-based SDK classes. It is used only for database storage. It was designed mainly for iOS applications. 8, which statement about iOS application development is true? Objective-C was used only for UI, not logic. Swift was introduced before Objective-C. Zip and Storyboard are programming language like Java. Swift succeeded Objective-C and became the modern language for app logic. Swift UI replaced XML used in Android. So provide the answer for number 8. Thank you for staying to the end of the class. Like I always say, there is a lot to learn, and if you are not subscribed to White Hat Developers, then subscribe because this is what we are here for, to help you learn and understand the concept of software development. See you in the next class.